Okay, so your substitute teacher should have given you back your let's try the competition. Is there a difference from the other day? I kind of scanned through them real quick just to see if there were some common mistakes, and I did see a few, and then some folks did it perfectly, but I wanted to make sure that you got a chance to see what did you miss and why, or if you got it all correct. All right, just a couple little things. All right, so we had the two different samples. And the question will be, are they independent samples or are they matched up and not really independent? And that kind of gives you a clue to question number 2 is these are matched up and they are not actually independent. Now, we first got a set of 13 items when we went to Publix, but then when we got a second sample from Kroger, it was no longer independent because we went and specifically chose the Rogaine, the drumsticks, the cat food, so that it would be matched up with the Publix item rather than, can you imagine if we randomly picked 13 items from Publix and 13 totally independent, randomly selected items from Kroger, that we would have most likely completely different products, and is that a valid comparison? And I wouldn't think so. You really have to get the same products. So they're not independent samples. And I want you to notice, of course, that we've got this difference column over here to show the difference in the prices, and it didn't matter which one you subtracted from which, but the way I had it set up, it made sense to say the Publix item minus the Kroger item to get this. So a positive difference meant that Publix was more expensive. A negative difference meant that Kroger was more expensive. In the end, we're interested not in the sum of all the X bar from list 1 or the X bar from list 2, but we were interested in the X bar from the difference row here, and so we were interested in the fact that it was a 94-cent difference, and that would have, since it was positive, that would mean that Publix on average was higher. There were 13 items, and the standard deviation of that, well, that was pretty significant, large deviation, and it's mainly coming from that Rogaine product. Okay, so moving along, I kind of talked about this. Did we choose each set of 13 items totally independent of the other set of 13? Actually, we didn't. We randomly chose Rogaine to start with at Publix, but we specifically chose the matching product at Kroger. So instead of a 2-sample, a 2-sample t-test requires 2 independent sets of data, but a matched pairs is no longer, I know it's 2 samples, but they're specifically matched up. They are dependent on each other from a standpoint, if you chose that product at Kroger, you got to choose that same product at Publix. And so that turned it into a matched pair, and it's no longer a 2-sample t-test, but a 1-sample t-test looking at the difference. All right, so that's going to be a big deal, is being able to distinguish between these two. In a 2-sample, I do just want to say that it always ends up that you have exactly the same number of items in each sample. Now, you can have a 2-sample significance test that does have the same item count in each sample, but if they're independent, then it's a 2-sample only when they match up specifically. Like on the Tough Mudder thing, we got Joe, and we got Joe before the training and after the training. Well, Joe was matched up with Joe, and so we were interested in the difference, and that was a 1-sample t-test with matched pairs. Okay. Pretty big deal if you can't tell. So the null hypothesis and alternative, this is where I saw a lot of difference in terms of the answers. And in words, I'm looking for the null is basically saying, hey, there's no difference between each matched pair set of items at Kroger and at Publix. Now that I'm looking at that, that's really referring back to the sample, but it's not between each matched set of items in the sample, but in the entire store. So make it clear that, if you were asked this, a hypothesis is talking about the population information, not a sample. Okay, now we're going to test it with the samples. In symbols, here we go. I got I've got some of this, mu1 equals mu2, or the difference in those is equal to 0, but that's under a 2 sample. All right, so we're going to distinguish. All right, the alternative in words, one grocery store is different than the other. I started to say higher. I mean, one is higher, either which one, but this is indicating a 2-tailed test at this point. And in symbols, the alternative is that the average difference is simply not equal to 0, versus over here the null was that the average difference was equal to 0. Parameter of interest, we're interested in the true mean difference of all the grocery items at Publix versus Kroger. Moving on to plan, checking randomly selected which 13 items to buy and sample from one of the stores, but we specifically matched at the other store. So it did have the random selection, and that's good. They were not independent, and that's because it's matched pair. 10%, yeah, we assume over 130 items at each store, and that was certainly a fair assumption. This normal and large sample question is the parent population normal? Well, they never said that. So if they had said that, then we'd be good to go. But they didn't say it, so we have to check this large sample thing. Our samples were not over 30 or equal to 30. If they had been, then we'd be good to go on this. Then the sampling distribution is expected to be normally distributed. But we were in this case. It was less than 30. The parent population was not specified, so we needed to look at graphs. So Shift Control W. Come on. Alt Shift W. Oh, there we go. Hallelujah. Because I wanted to show you this. So I got my data in here, list 1, list 2, and list 3. List 3 being the difference in those. And now I'm going to go to second stat plot, and I'm specifically looking at list 3. I'm looking at the difference. And I'm going over here to this and hitting the histogram and zoom number 9 just to make sure it's all good. And the data is skewed to the right. It does have an outlier. I am concerned about that. And it's certainly notable that maybe I should proceed with caution. I am going to check the other graphs because I have the data, and I'm going to just look at the box plot and graph and zoom number 9. I don't think it's going to make a difference. Okay, so yeah, I can clearly see my one item way out there. The box plot does give me some assurance that it's not horribly skewed. It just has one nasty outlier. Okay, so I kind of like that perspective. And then the last graph we looked at was the normal probability plot, and that puts it on a diagonal, and you definitely want to zoom number 9 when you look at that one. And so I'm going to say proceed with caution on this one. Because of the one outlier, I don't think they could ding you on scoring this. I know I wouldn't if you said proceed with caution. If you also said, hey, it's all good except for there's one big outlier, then I would kind of be okay with that as well, And Hold Shift W. I think I'm going to go back to this. Okay, nice. All right, so we're checking that out, and now going over here. Formula with symbols. So most of you got this. So that mu of the difference was 0. Here's the numbers. I had a variety of answers here, and I think it was people getting either list 1 or something else in there. But check over your numbers and see if you maybe messed up, pulled that off the wrong list. So anyway, this was the correct one, and it yields a t-score of basically 1, which we know is not extreme. But with the degrees of freedom of 12, which is n-1, then we get this value. I got that straight out of the calculator. Alt Control W. Oh, hold on a second. Okay, there we go. And then I'm going to go over here to stat test, and I'm doing a t-test. Why not 2 sample t-test? Because it was not 2 independent samples. It's 2 samples that are matched pairs. That's treated as a 1 sample t-test. And I've got my data in there, and that came from list 3. My average difference of the 13 items, the standard deviation, the 13 there, I put in not equal to. So I think there were some people that put in 1-tailed, I'm not sure. And then calculate, and you know what, now that I'm looking at this, I think I erroneously doubled it. I did. Okay, so I'll show you where I made a mistake. And so I know that some of you were right about this. This p-value that's in here is already doubled. So if I did this stat t-test and I had said give me a one-tailed test, something like that, then that, okay, now this makes sense. That p-value, 0.168 or 0.17, is a one-tailed test, but when you do it as two-tailed, you would double that and get the 0.3233, something like that. All right, so let me go back to, oops, sorry, hang on. Shift W, there's some funky stuff. Okay, so going back to this, I see that I did this doubling thing. Oops, no, that was already doubled with the calculator because I told it that the alternative was this. So if I did the greater than or the less than, then I would have got half of that. Then I would need to double it. So, oops, okay, got me. All right, so degrees of freedom of 12, and compare that p-value very high. Well, let's go back to the 0.336 or whatever it was. It's still extremely high versus the assumed 0.05. Failed to reject the null. There is no evidence for the alternative that prices are different between prices of all groceries at Kroger versus Publix. I'm referring to the population here when I talk about this and not the samples. The samples helped me come up with this. What difference would it make if we changed it to a one-sided test? Well, that p-value would be cut in half, but so that, yeah, then it was at 0.168, and that was still very high, and so it wouldn't really make a difference on our interpretation of the result. All right, sorry I had to endure that, but I think that was good from a standpoint of knowing that you know the difference between this. Your assignment from here is to take a look at this other, well, no, I'm sorry, it's a learning card. It's in your system, and I want you to, or in your book there, and I want you to read through this and decide. One of these is a two-sample significance test, and one of them is a one-sample matched pairs. And just make sure that you can understand the difference, and it really boils down to that independence question, and then it impacts how you hypothesize it and which test you're going to run. All right, and in the learning card, just calculate the little p-values, and let's see what we got from there. I'm going to also assign you an appropriate Desmos activity to kind of finish out the day. It probably will not take up the whole block time, and then I'll have to share those results with you prior to you taking the test. So the test is on Friday. If I see anything really out there on the Desmos activity, I'll give you a heads up on that, but I suspect you guys kind of got it at this point. If you want to do anything in sapling, we're in chapter 10 and chapter 11. Those practice tests are there. I'll go ahead and assign those just so, but I won't count them as a grade, but so you can look at them and make sure you're good with this stuff. All right, I will see you Friday, and sorry for being out 2 days in a row. See you when I see you on Friday.